we're back to our lab. First thing we're going to do is we're going to assign IP addresses to router 1, interface F00, router 2, interface F00, router 3, interface F00, and router 4, interface F00. So let's go into router 1, maximize it, and let's look at our interface F00. So show interface fast Ethernet 0/0. Now, real quick, I'm going to go back. Why am I assigning IP addresses to these 4 interfaces? Well, because they reside on the same LAN. You see this LAN in the middle with the 4 switches. So all 4 of these routers reside on the same data link, on the same LAN. So we're going to pick an IP addressing scheme to assign to router 1, router 2, router 3, and router 4 F00. I'm going to use the network 150.101.45.0. And the mask I'm going to pick for 150.101.45.0 is a /29 mask, which is 255.255.255.248. Why did I pick a /29? Because when you write it out in binary with a /29, the value of the last bit on is 8. So you get addresses between .1, which is a first valid address, and .6, which is your last valid address. .7 would be my broadcast, and .8 would be where my next network starts. So since I have 4 routers, I need 4 addresses. So a /29 is the closest fit. /28 would yield me 15 addresses because the value of the last bit turned on is 16. And /30 would yield only 2 addresses because the value of the last bit on is 4. Minus 2 is 2. With /28, you get 15 total addresses because the value of the last bit turned on is 16. So 16 minus 2 is 14. 14 addresses is way too many. With /29, the value of the last bit turned on is 8. So minus 2, I get 6 addresses. Yes, I'm wasting 2 because I only need 4 here, but that's the least amount of waste. So I'm going to go back inside router 1 and look at my F0/0 interface. And I see that by default, a router interface is in administratively down mode. So by default, a router interface is administratively down. The MTU of this interface, or the maximum transmission unit, is 1500 bytes, and the bandwidth is 100 megabits per second, or 100,000 kilobits per second. There's another command you can use to look at all the router interfaces at the same time. The command is, and it is actually one of my bread and butter commands. This is the command I execute first when I'm solving a problem and I run into a problem in my lab or at work. And the command being show IP interface brief. And you see this router has 1, 2, 3, 4 interfaces. 2 of them are Ethernet interfaces, and 2 of them are serial interfaces. I'm just going to tell you that fast Ethernet 00 and serial 000 are in use. The other 2 are just sitting there unconnected to anything. The IP address is not assigned yet, and the port is in administratively down mode. Now, to make changes to a port, I first need to go into that port. So I'm going to go into interface fast Ethernet 0/0, 0/0, and now I'm going to assign it an IP address. So since this is router 1, I'm just going to make this 150.101.45.1. So to assign an IP address, the command syntax is the word IP, then the word address. Then if I execute the help feature, it asks me for the IP address, which is 150.101.45.1. Then once again, if I execute the help feature, I'm asked for a subnet mask, which is 255.255.255.248. Unfortunately, and I hit enter for the command to take, unfortunately, Cisco routers up until now don't do the slash feature when you're assigning IPs. It would be nice if we could have just said IP address 150.101.45.1/29, but it just doesn't work that way. Next, since the interface by default is in administratively down mode, I'm going to negate the shutdown command. So by default, the port is shut down. I am going to add a no in front of it and hit enter, and that brings the port up. At this point, if I look at my show IP interface brief command again, you will see that fast Ethernet 00 is up and up, which is good. You want to see up, up. I'm going to save my work. I'm going to use the shortcut command. I'm going to say do write mem, or short. The short form is just do write, or I can say do WR. Next, I'm going to go to router 2 and assign an IP address. And router 2, for some reason, has all its configuration missing. So I'm going to quickly go ahead and do that. No IP domain lookup. Host name R2. Line console 0. Logging sync. No exec timeout. And we are done. Then I'm going to go into interface fast Ethernet 0/0 and assign it an IP address of 150.101.45. We can pick .2 because that's within the valid range. Do I need to exit out of config line mode to go into the interface? No, I don't. I can simply type in interface fast Ethernet 0/0. Hit enter, and the prompt pops me over from config line mode to config IF, which stands for interface. Config interface. I'm going to assign it an IP address, 150.101.45.2, the mask, and then no shutdown the link. Again, bring it up. Look at my do show IP interface brief command, and I see this interface is up, up. At this point, I save my work and move on to router 3. Router 3 is again missing, this is weird, all its config. So no IP domain lookup, host name R3, line console 0, logging sync, no exec timeout. Okay, that takes care of our housekeeping configs. Next, I'm going to go into the interface, fast Ethernet 00, and give it an IP, 150 IP address. I could simply type IP ADD, but I don't want to confuse anybody. 150.101.45.3, then the mask. And again, execute the no shutdown command. Next, I'm going to save my work, make sure this doesn't go missing again, and then look at my interface with the do show IP int brief command. Again, it says up, up, and I'm happy. I am going to go to router 4 and do the same. Hopefully, router 4 hasn't lost, and it has lost its configs also. Something's going on. No. I know router 4 has lost its configs from yesterday because I already had assigned a router name as R4 and I don't see one. So quickly do the housekeeping, no IP domain dash lookup, and then line host name R4, then line console 0, logging synchronous, no exec timeout, and I'm done with my housekeeping. I saved my work. Next, I'm going to go into interface fast Ethernet 00 and assign it an IP address of 150.101.45.4. So router 1 is .1, router 2 is .2, router 3 is .3, and router 4 is .4. It works. And the mask 255, 255, 255, 248. No shut my interface to bring it up. And check to see if it really is up. So I say do show IP interface brief. If I could type int brief, and I see that the interface is up, and I am happy. Now, I'm going to go test to see if this actually worked. So I'm going to test connectivity from router 1 to router 2, 3, and 4. And I'm going to use the ping utility, which uses the protocol ICMP, or Internet Control Messaging Protocol. I'm going to ping 150. So I'm sitting on router 1. Remember, guys, I'm sitting on router 1. So ping 150.101.45.2, which is router 2's address. I'm going to hit enter. And I had an 80% success rate. The first ping failed. The first ICMP packet sent failed. The next 4 succeeded. There's a reason for that. If I do a second ping to router 2, all 5 will succeed and I get 100% success. I will ping router 3 now. Just change the last octet. Up arrow key, bring up the command, change the last octet to .3. And once again, you will see an 80% success rate. But if I ping it again, so you see an 80% success rate. 4 out of 5 pings went through. 1 failed, the first one. And the second ping yields 100% success rate. 5 out of 5 pings went through. Lastly, I'm going to ping router 4. And once again, you're going to see an 80% success rate, but a second set of pings that I send yields 100% success rate. 80%, 100%. Think about why this is happening. Well, the answer being, the first ping fails because router 1 is doing the ARP process. It doesn't know router 2, router 3's, or router 4's MAC address. So it cannot build the frame to send over the ping inside of the frame to router 2, 3, or 4. So once that ARP process, the request and reply process is happening, the first ping times out. Once that process has happened, router 1 has already stored router 2, 3, and 4's MAC address in its ARP table. So since they're already stored, the second time I ping, I get a 100% success rate. Because router 1 already knows the destination MACs and can immediately go ahead and build the frame to encapsulate the ICMP packet in. So let's look at our ARP cache or ARP table with the command show IP ARP. And I hit enter. And you see router 2's address is 150.101.45.2. This is its hardware address or its MAC address. And it's been in this table for 2 minutes. This is router 3's IP address, 45.3, and this highlighted portion is router 3's MAC address. And it's been in the ARP cache or ARP table for 1 minute. This is router 4's address, 150.101.45.4, and this is its MAC address with the MAC address being in the ARP table for 1 minute. Now, you don't see an age attached to router 1's own IP and MAC binding because my MAC address won't age out of the ARP table. It can never age out. If I, for some reason, wanted to clear my ARP cache, I could execute the command clear IP ARP. Okay, so maybe it is clear ARP. Clear IP ARP works on some routers. You will notice as you progress in your network engineering career, sometimes there are minor differences between the IOSs. So one router might have one command and then it won't work on another router and you hit the question mark command to figure out what the proper command is. So I could clear out my ARP cache if I wanted to, and it really didn't work on on this device on Packet Tracer, but the clear ARP cache command will clear out your ARP if you need it to for any reason. Now let's make sure this 00D0, D3B6, 4B01 is actually router 2's MAC address. Well, let's find out. I will minimize this and go to router 2 and look at the interface in detail. I say show interfaces fast Ethernet 0/0. And the MAC address of this interface is 00D0 D3B6 B4B01, which matches what is in router 1's ARP cache or ARP table. Now, what if I asked you guys, so we've looked at the ARP table, we know how the ARP process happens, we know how ping happens. Let me show you another command. So if I say debug IP ICMP, ICMP being the protocol that ping uses, the debug command, what it does is takes the internal processing of a router and puts it on screen. A big no-no in production. You do not use the debug command in production. You can be fired for issuing a debug command at work or in production. So this is only used for learning purposes. So if I say debug IP ICMP and I go to router 4 and I also say debug IP ICMP. So now let's send a ping from router 1 to router 4. Ping 150.101.45.4. You see that I sent 5 ICMP messages. So it says echo reply received because router 1 sent an echo packet over to router 4. It was received from the source, router 4, and the destination was us. So this was the echo reply that was received from router 4. If you go to router 4 and check, router 4 will say, I sent an echo reply. My source was 150.101.45.4, which is its own address, and the destination was .1. Let's turn off debugging, U, which stands for undebug, and all, undebug all. I could have possibly said, I'll do it a different way on router 1. I could have possibly also said, no debug IP ICMP, except U space all is so much quicker. Now I'm going to say debug IP packet. And also on router 4, I'm going to say debug IP packet. Please remember, guys, do not ever use the debug command in production at work. You can be fired. It's a fireable offense. Because there is so much traffic flowing through a router at a given time, if you say debug IP packet, your screen will freeze and the router may crash, trying to put all that traffic on screen for you. It is very process intensive. So do not do this command at work. I cannot stress enough. Anyhow, now I send a ping from router 1 back to router 4. So I'm pretty sure I have it in my command history. I use the up arrow key to pull it up. And I send the ping. So let's look at one of the pings that I sent, because I sent 5. The source address was 150.101.45.1, which was my local address on router 1. The destination, D for destination, address was 150.101.45.4, and it was routed via the routing table. This we will see tomorrow what this means. Right now, this is not supposed to make sense to you. Then you received a packet back, which is the echo reply, coming back from router 4, 150.101.45.4, and the destination of that packet was 150.101.45.1, which is you, or router 1. You should have also seen a similar occurrence on router 4. You saw, let's look at this one right here. You see that the source address for the inbound packet was 150.101.45.1, and the destination was your own. own router, which is router 4, the one we are sitting on right now. And then I sent a message back, which was my echo reply, to source address 150.101.45.1. No, source address 150.101.45.4, and the destination was 150.101.45.1. This was my echo reply packet, and this was the echo that I received from router 1. I'm going to turn off debugging, and we're going to do one more thing and then commence for the day. Use space all to turn off debugging. Now, if I asked you guys a question, I want you to test connectivity from router 1 to router 2, 3, and 4 in one command. How would you do it? Simple. For the 150.101.45.0/29 network, 150.101.45.7 is my broadcast address. Let's see what happens when I ping that address. This ping should go out to everybody. And it does. It goes out to 2, 3, and 4 5 times, and 2, 3, 2, 3, and 4 reply back 5 times. Going to turn off debugging and save my work. And this concludes this part of the lecture. Thank you.